Hi Rockridge, it's Mrs. Berger. Today we're going to be talking about factoring special cases. First we're going to do a little bit of a warm-up that sort of sets the stage for today's work and reminds us what we did last class. So let's dive into that warm-up. Hopefully you've had a minute to take a look at it first. Sorry about that. Here we go. There it is, warm-up. This first set of two problems here is supposed to start to set the stage for what we'll see today. And if you look at these, you'll notice that looks like something from Unit 1, right? These two things look like conjugates of each other. Do you remember conjugates? We used those for when we had a square root or a root of some kind or an imaginary number. We used conjugates to rationalize denominators. And the great thing about conjugates was, what was that? It was the two middle terms canceled out. Remember that? So something similar is going to happen here. Let's see what happens here. If we FOIL this out, which is what finding the product means, finding the product of these two things is multiplying them together or FOILing them out, you'll end up with s squared minus 2st plus 2st minus 4t squared. And just like what happened with the conjugates from Unit 1, these two middle terms cancel. So we're left with s squared minus 4t squared. If you notice, this is something squared minus something squared, or a difference of squares. So later today, we're going to come upon something like this in the maroon, and we'll have to factor it back down into something that we started with back here in the black text. Okay? So again, we're just setting the stage for later. Remember that if we FOIL these two things together, we end up with a difference of squares. So if we were presented with a difference of squares, we could factor that down to these conjugates here. Let's see how that happens again in number 2. If we were to multiply them together, we would have 9x squared minus 6x plus 6x minus 4. Once again, the middle terms cancel. And we have a difference of squares. If you're presented with this difference of squares, you can factor that back into this. And we'll show you how to do that with a little tool that we'll use. But that's, again, just laying the groundwork for what we'll see later. Alright, so let's go back to the stuff that we did last class, factoring a trinomial, a quadratic trinomial. Remember, the first thing we should always do is check for a greatest common factor. I do not find a greatest common factor here. Someone asked that I demonstrate, instead of foci, which is, by the way, my favorite, someone asked to demonstrate how to do this with slide and divide, because on the homework it was a little confusing. So let me do a slide and divide this time. All of my students know that I don't prefer this method, but for those that do, what we're trying to do here is think about this problem first as x squared plus 17x, and then let's multiply the first and the last, so it's plus 72. Alright, so now we're thinking about it in this manner, and we're trying to think of things that multiply, or are factors of, 72, whose sum is 17. So we think and think and think on that, and the numbers that we come up with are 9 and 8. So what we do is we rewrite this as x plus 9 and x plus 8. Now, that is the sliding, and now we're about to divide. So let's do the dividing part. What we need to divide by is this number here. So both of these need to be divided by the 6. But these do not divide evenly, right? It's not like we're dividing 9 by 3 and getting a 3. What needs to happen at this stage is a reduction. So we try to reduce this fraction down as much as possible. So we'll reduce this to 3 and 2, and we'll reduce this to 4 and 3. Okay, this step must happen wherever it can. Once you're finished with that, we slide these bottoms back to the beginning. Okay, we slide these denominators back to the beginning. and build a 2x plus 3 and a 3x plus 4. Okay, so those are our factors. We didn't have a greatest common factor come out, so this is our final. All right. So let's move to 4. Question number 4. Is there a greatest common factor? Yes, there is. There's a greatest common factor. In this one, it's 2. So let's pull that 2 out and leave behind an x squared plus 3x plus 2. This number in front of here is an invisible 1, so we actually don't need to use foci or slide and divide or split the middle term or guess and check. We don't have to. If you would like to, you can. We actually can just sit here and think to ourselves, what multiplies to 2 and adds to 3? Okay, so what multiplies to 2 and adds to 3? 2 and 1 serve that purpose. So we can build our factors, and they're both positive. We can build our factors like that. Since we took a GCF out at the beginning, we need to bring that back in for its final curtain call and its final answer. Number 5, once again, we are faced with a greatest common factor. So let's pull that out. That GCF for number 5, let's make that a negative 5 that's coming out so that this ends up a positive. So 6x squared plus 5x minus 6 is what's left behind. All right, now choose your favorite method for when you're dealing with a non-1 in front of here. Everyone knows that my favorite is foci, so I'm going back to foci. So I need to find factors of negative 36 whose sum is 5. And while I'm thinking of what that could possibly be, I'm populating my chart with this number here. All right, I'm thinking and thinking, or I'm looking at my calculator with the calculator trick we learned. It's gotta be some version of 9 and 4, right? I'm trying to find 9 and 4 multiplies to 36. I gotta get it to 5. So one of these has to be negative. It's gotta be the 4 that's negative. Okay? So that's the thought process that goes on there. Once you're done building this tool for yourself, use the tool to simplify. 2 and 3. Another simplification happens over here. Doesn't always happen on both sides. It's always at least one. But this time I have 2 simplifications. So let's do 3 and negative 2. If you have a negative, keep it in the quadrant it started in. Don't move it around. Keep the negative in the quadrant you started with. All right, let's use our chart. Let's use our tool to build our factors. 2x plus 3. 3x minus 2. Am I finished? What did I forget? This negative 5 back here, this GCF needs to come back in the final answer. All right, so that's the warm-up. Hopefully that's ringing some bells, giving you some reminders of what we learned last class. So let's launch into today's new lesson. Today's new lesson is factoring using special cases. So if we come upon things that look a certain way or are built a certain way, we can memorize what their factor format is or what their construction is. Okay? So this is a little template. If you come upon something that is something squared minus something squared, the template for those factors, if it's a squared minus b squared, is a plus b and a minus b. So we saw that in the beginning of the warm-up, right? We saw those conjugates were the factors of something that ended up like this, okay? So you can walk through this example with us here. Always look for a GCF, right? Always look for a GCF. So if you were faced with this, you should first see that there's a greatest common factor of 3 on both of these. That's the greatest common factor. So pull that GCF out and then stare at what's left. What's left is something perfectly squared minus something perfectly squared. And so if this is a squared and this is b squared, follow the format. Follow the template that we have. We find out that the original thing was x, and the original thing here was 3y, so we build an x plus 3y and an x minus 3y. We make a note for ourselves that a must have been x, and b must have been 3y, and so we make use of those a's and b's in our little template here to build the final answer. Okay, that's how these work. All right, so let's take a look at number 1. First and foremost, is there a GCF? Look for it, look for it. I don't see one. I don't see one. I do see that there is something squared minus something squared, so I immediately think, all right, we're going to think of this as a squared and this as b squared. If that's the case, what must a have been? A must have been x. What must b have been? B must have been 5. Let's follow our little template for what happens when we have a difference of squares. So follow the template and build your factors. They must be x plus 5 and x minus 5. Order doesn't matter. You could have said x minus 5 and x plus 5. That would be fine. One needs to be negative and one needs to be positive. If we look at number 2, let's first look for a greatest common factor. I don't see one, so I immediately launch into defining what a and b must have been. If this whole thing was a squared originally and this whole thing was b squared originally, what must have been squared to get here? To get here, I squared 4a. To get here, I squared 1. Now that I've identified a and b, I build my factors. 4a plus 1 and 4a minus 1. Number 3, start out by looking for a greatest common factor. There is one in this case. It's 2. So leave behind 9x squared minus 4. Now I'm looking in here, and I'm seeing that this is something perfectly squared and this is something perfectly squared. So we can use our template. So this is a squared and this is b squared. So a must have been 3x. B must have been 2. So I'll build my factors. 3x plus 2 and 3x minus 2. Don't forget, we originally took out a greatest common factor, so that's got to come back in our final answer. Number 4, you may not think there's a greatest common factor. There is. I will definitely show you the way to take a greatest common factor out on this one. You could also switch the order of terms, so if your teacher taught you to switch the order of terms, that's fine too. I like thinking about this as there's a greatest common factor of -1, so that's how I'm teaching it. So we're going to take out a -1 from each of these and leave behind a 16a squared minus a 25b squared. Okay? Alright, so let's take a look at this now. We have something squared here, something squared here. What must they have been originally? This must have been 4a originally. This must have been 5b originally. So we build our factors, 4a plus 5b and 4a minus 5b. Don't forget we took out a -1. And that's that. Number 5, I'll give you a minute to think about number 5. First think, is there a greatest common factor to pull out? No, there's no greatest common factor. What would we do with this problem? If you notice, this is a sum of squares. You definitely have something perfectly squared here, and you definitely have something perfectly squared here. But it is not a difference of squares, it is a sum of squares. Our pattern only works for a difference of squares. Our pattern only works if it's something squared minus something squared. That's not what this is. This actually can't be factored, and if you recall, we had a vocabulary word that we used to say something that couldn't be factored. We call it prime. If it can't be factored, it's prime, and that's what number 5 is. Alright, that was exciting. Let's move on to number 6. Once again, we have something squared minus something squared. We do not have a greatest common factor to pull out. So let's go ahead and start identifying what got squared. So first and foremost, x to the 4th. The thing that got squared to make x to the 4th must have been x squared. because x squared squared is x to the 4th. X squared to the 2 power is x to the 4 power. The thing that got squared to make 16 must have been 4. So we'll build our factors, x squared plus 4 and x squared minus 4. However, we are not finished. We are not finished. Why are we not finished? Because we have made ourselves another difference of squares. This is not fully factored. We have to keep going. The directions on your quizzes and tests and on your final SOL will be to factor completely. This is not factored completely. This is another difference of squares. So let's sit over here and make a note to ourselves. What was squared to make x squared? It must have been x. What was squared to make 4? It must have been 2. So let's break this into x plus 2 and x minus 2. This is prime, so we'll just bring it along for the ride. Do a last final check. We're all good. This is the fully factored number 6. All right, let's move on to another special case. Once again, this special case talks about factoring a 2-term problem. This 2-term problem is not a difference of squares. It's either a sum of cubes or a difference of cubes. The factored form of something cubed plus something cubed follows this pattern. The factored form of something cubed minus something cubed follows this pattern. You will need to memorize these. It will not be available on your test. Something you can use to help you remember this is a little mnemonic, SOAP. You can also use SOFAS. I'll just use SOAP here. If you prefer SOFAS, you can also memorize this. I can easily remember that the format of this is always a and b, a squared, ab, and b squared. The only difference between this memorization and this memorization are the signs. When I have a sum of cubes, this sign is positive, this sign is negative, and this sign is positive. When I have a difference of cubes, this sign is negative, this sign is positive, and this sign is positive. But the terms are all of the same format. So if I can remember the terms, I can use SOAP to help me remember the signs. Here's what SOAP means. If you have a sum of cubes, the sign here is the same. The sign here is opposite of the original. The sign here is always positive, regardless of what was here. SOAP also works here. The sign here is the same as the original. The sign here is opposite the original. The sign here is always positive. So if you can remember the first term is an a and b, and the second term is an a squared, ab, b squared, SOAP will help you remember the signs that go in between. Here's an example. If you were faced with 8x cubed minus 27y cubed, you have a difference of cubes, something cubed minus something cubed. Let's first identify what got cubed in the first place. A is the cube root of this, or 2x. 2x was originally cubed to make 8x cubed. B must have been 3y, the cube root of this. 3y cubed made this 27y cubed. So you use this A and this B in our template for difference of cubes. The difference of cubes template is here. Same sign, opposite sign, always positive. So we take A, which is 2x, minus B, which is 3y. That's the match there. This match here, a squared, remember you need to square this whole thing for a squared. So a squared is 4x squared. ab is a times b, 6xy goes there. B squared is this whole thing squared, so b squared is 9y squared. Let's do some work on our own here. So let's see. The first example. We check for a GCF always. Is there one here? No, there's not. We have a sum of cubes, something perfectly cubed plus something perfectly cubed. Let's think about what originally got cubed to make this. X was originally cubed to make that. 2 was originally cubed to make the 8. Now, let's fill in our template. The first factor is A and B. The sign is S for soap. S, same. The second factor is A squared in this spot here, so it's X squared. A times B in the middle, 2x, and B squared on the last one, so 2 squared is 4. Now let's fill in our signs. Same sign, opposite sign, always positive. Those are your factors. Let's work on number 2. Is there a greatest common factor? I don't see one. So let's start identifying what we have. Something cubed minus something cubed. Let's think about what was originally cubed for each of these. To get to this, I had to cube 4x. To get to this, I had to cube 5. Now let's use that to build our factors. The first factor has just an a and a b, and the sign is the same. The second factor has a squared, or 16x squared. The second term is a times b, which is 20x. And the last term is b squared, or 25. Now let me fill in my signs. Same sign, opposite sign, always positive. And I'm finished. Number 3, I'll check for a greatest common factor. I don't see one. So I think to myself, what must have been cubed to make the first term, and what must have been cubed to make the second term? Because it's a sum of perfect cubes. To get to this, 7m must have been cubed. To get to this, 4n must have been cubed. Now I build my factors. The first factor always has just an a and a b, and the sign on that one matches. It's the same. The second factor has an a squared, or 49m squared for this one. The second term is a times b, or 28mn. And the last term is b squared, or 16n squared. Now let me do my signs. Same, opposite, always positive. So that's our second special case. If you come across a two-term expression that needs to be factored, if the first and second terms are both perfect cubes, that's the strategy you'll use for those. Special case number 3. If you come across something that is a trinomial, 3 terms, that appears to have this form, something squared here, something squared here, and the double of each of those originals here, that can be factored as a plus b squared. There's also a negative version. It must satisfy these 3 conditions for it to match this special case. The trinomial has got to have the first and last terms perfect squares. It must have no negative sign before the first or before the last. These both have to be positive. This has to be true, this has to be true. And the middle has to either be positive 2ab or negative 2ab. Now, as a side note before we demonstrate this, we are talking about trinomials here. You already have 4 perfectly good plans and strategies for tackling trinomials. So you could actually go forth with foci, or split the middle, or slide and divide, or guess and check to work on these. You could definitely default back to that. But there are certain times when we see things that appear to be perfect square trinomials, where memorizing this could be useful and make things a little faster on us. Okay? So this is one more thing to add to your bag of tricks. If you've got too much to memorize, you won't necessarily have to memorize this because you could always fall back on your original way to factor a trinomial. But let's see how this works. If we have x squared minus 10x plus 25, we immediately start looking and saying, wait a second, this looks like something squared and something squared to me. Let me check and see if this middle term is 2 times a times b. Well, a must have been x, and b must have been 5. And a times b times negative 2 is negative 10x. So I have an example of this special case. So if I've memorized the format of something that looks like this, having factors that look like this, I can immediately jump to x minus 5 squared as my factored form. If you had done this using foci or split the middle, etc., you would have ended up with x minus 5 times x minus 5, which is the same. So let's demonstrate this on 2 problems. Number 1, we come across this, and we notice that we've got an a that is an x, and a b that is a 6. Let's think about what 2ab would be. 2 times 6 is 12, 12 times x is 12x. Is that present here? It is. So I have an x plus 6 squared. Let's look at number 2. Number 2, let's identify what got squared to make this. It must have been 2x. What was squared to make this? It must have been 3y. This is positive, so let's see if 2ab is what this is. 2 times 2 is 4, 4 times 3 is 12, times x times y. That is in fact what's there. So we can build our factors as 2x plus 3y squared. Our last special case for today happens when we come across 4 terms. Up to this point we've been looking at 3 terms in our last lesson, and then earlier today we looked at 2 terms, and then we looked at a special case for a very special 3 terms. Grouping will be used if you're faced with 4 terms. When you have 4 terms, you should first split them into 2 groups. I'll do this as the blue group, and I'll do this as the orange group. For each group, find the greatest common factor. Here, the greatest common factor is 3x. So pull that greatest common factor out and leave behind an x minus 4. Here, in the orange group, the greatest common factor is negative 5. So I pull a negative 5 out here, and I leave behind an x minus 4. This matches, so it is my first factor, x minus 4. The remainders make up my other factor. 3x minus 5 is my other factor. This is the factored form of this 4-term expression. Those that do split the middle term already have some great practice with this. This is how split the middle term works. Alright, let's take a look at an example. Example number 1 did half of our work for us. They've already broken it into 2 groups and taken the greatest common factor out. So they've already gotten us to this first step here. So let's finish their work for them. Let's take x minus 2 as one of the factors, and 5x squared plus 3 as the other factor. Now we've completed their work for them. You could have listed 5x squared plus 3 first, before the x minus 2, and that would have received full credit. Let's work on number 2. Let's do the blue group as the first 2 terms, and the orange group as the second 2 terms. Pulling the greatest common factor out of the blue group, we find that there is an 8r squared. Leave behind an r minus 8. Looking at the orange group, We don't have anything really common to there, so let's make a note to ourselves that there's an invisible little positive 1 here, and that it's already prime. These must match. If they don't match, you might not have pulled out the greatest common factor. So let's build our factors. R minus 8 is the first one. The matches is one factor. The leftovers are the other factor. The purple is it. That's your factored form. Number 3. Let's build two groups. I'll have a purple group and a pink group. For the purple group, let's find the greatest common factor. It's got to be 4v squared. Leave behind a v minus 3. Turn to the pink. The greatest common factor in the pink is negative 5. Leave behind a v minus 3. These match, so I'm good to move forward. If you had pulled out a positive 5, these wouldn't perfectly match, and so keep going and pull out a negative 5 to make sure that these match. Let's build my factored form. V minus 3 is one of them. 4v squared minus 5 is the other. That's my final. Number 4, let's group the red group, and let's do the pink group. The red group has a greatest common factor of just r squared, right? We can't take a 2, we can't take a 3. R squared's the only thing I can pull out. So let's leave behind 2r plus 3. Pink group, my greatest common factor appears to be a negative 4. So let's leave behind a 2r plus 3. Oh good, these match. Therefore, I will take 2r plus 3 as my first term, my first factor. And then r squared minus 4 as my second factor. However, I'm not finished. I have not fully factored this. Hopefully you noticed that r squared minus 4 is a difference of squares. Remember the first special case we learned today? This is a difference of squares. So let's talk about what got squared to make the first thing and what got squared to make the second thing. The a term must have been r, and the b term must have been 2. So continue to factor this into r plus 2 and r minus 2. And bring down this 2r plus 3 because that one's prime. Now we are fully factored. We can't split any more of these into any more pieces. This is the fully factored form. This would get you full credit. The blue would not get you full credit. It is not completely factored. Alright, the remainder of the lesson has some problems for you to try. I'd like to spend a little time talking about the strategy you should use for each of these. And this is how you should approach problems on the quizzes or tests. Look at what you're being faced with and jot down a strategy for each. So for the first one, the strategy here is going to be based on the fact that we have 3 terms. Not 2, not 4. We have 3 terms. And I don't notice that there are any specific special cases for these 3 terms. This isn't anything perfectly squared here, so I can't have a special case there. So I'm going to go ahead and use my standard method for factoring 3 terms. My favorite is foci, so I'll make a note to myself that I'm going to use foci on this one. If you use slide and divide or some other method, jot that note for yourself. But that's the plan you're going to use for that one. So I'll let you try that one. Let's move on to the next one and talk about what we're going to do for this one. Now this is 2 terms. I see a greatest common factor on this one, so let's pull that out before we make any decisions. Pull the greatest common factor out and look at what we have left. This is a perfect cube plus a perfect cube. So I'm going to go to my format for sum of cubes and continue this work based on that pattern. I'm going to identify the A and the B and follow the format for a sum of cubes. Follow the template for sum of cubes. Alright, so I'll go back and look at that one. Number 3 is another trinomial. It doesn't look like it has a greatest common factor. It doesn't look like I have a perfect square here or a perfect square here. So I'm going to use my favorite method, foci or slide and divide or split the middle, to factor this trinomial. So I'll come back to that and work on that one. Number 4 is 4 terms. The way we deal with 4 terms is grouping, always. So I'll make a note to myself to group these and factor by grouping. This will be a group and this will be a group. Number 2 appears to have a greatest common factor. So let's see what happens after we pull the greatest common factor out. Pull the 2 out and leave 4x squared minus 25. What's left behind appears to be something squared minus something squared. So I'm going to make a note to myself that I'm going to follow the difference of squares method. I'm going to identify A, I'm going to identify B, and I'm going to build an A plus B and an A minus B. And these are misnumbered by accident. This is question number 5. Question number 6. Question number 6 is a trinomial. It looks like I've got something squared and something squared. And it looks like if A is x and B is 3, this looks like double that. So I actually do have a special case here if I wish to use it. If you would like to use the special case, sum of squares, jot that note down. If you're not terribly comfortable with that, you could also jot down foci or split the middle, whatever your favorite trinomial method is. So make that note to yourself for later. Fix the numbering on these. Number 7, let me look for a greatest common factor. I don't see one, so let's look at what we're staring at here. We've got something cubed minus something cubed. So I'm going to make a note to myself. I will use the difference of cubes template. I'm going to identify A and B and fill in my template for difference of cubes. Number 8 does not appear to have a greatest common factor across all of these, so I'm good there. I have 1, 2, 3, 4 terms, so the way I deal with 4 terms is grouping. So I'll make a note to myself, I'll be using grouping on this one. Number 9 is also 4 terms, so I know I'm going to be using grouping. Are there any GCFs I need to pull out first? No, I don't see any, so I'm just going to go ahead and make a note. This is a grouping. So I'm going to let you work on those. There is an online key that you can check your work against, but now that you have a strategy, and this is certainly what I would do on a quiz or test, look at what you have, count the terms, see if there's a special case, set forth a strategy for each, and then go ahead and go after them. All right? Go ahead and take some time to try those and check your work against the key. Then work on your independent practice.